So now start the class. All of you listen. So in the last class we have discussed about the what? When the voice is clear, my voice is clear, all of you?
Yes.
Okay.
Okay. In the last class we have discussed about what? Reaction mechanism of transition metal complex. Which type of reaction mechanism we can discuss about that? Two different types of reaction mechanisms are there. So they are what? SN1, SN2, and we are discussing about SN1, SN2.
Praveen sir, నేను
Now,
కోటేశ్వర.
what?
సార్ నేను కోటేశ్వర. హలో.
Hello.
సార్ మీ నేమ్ టైటిల్ మార్చండి సార్, మీ పేరు రికార్డింగ్ లోకి ఇబ్బంది లేదు.
టైటిల్ మార్చాలా సార్?
అఖిల్ అని ఉంది కదా, అది మార్చేసి ప్రవీణ్ అని పెట్టండి. అది మార్చండి, రీనేమ్ చేయండి ఇది.
సరే సార్.
ఓకేనా? థ్యాంక్ యూ.
ఓకే. Okay, now we have start the class. So in the last class we have discussed about the what?
Last class.
SN2 reaction mechanism. SN2 reaction mechanism. That is which type of? Another name is what? Association mechanism. Another name is the association mechanism. That is the coordination number 6 is converted into 7. Again 6 converted into the 6. This is the mechanism of in that reaction. Okay. So some in this reaction is undergoes to the acid hydrolysis reaction. That means in this SN1 and SN2 reaction mechanisms are undergoes to the acidic medium. That is called what? Acid hydrolysis reaction. Okay. So some factors are influenced by the reaction mechanism. Which path one is the more favorable path one? So the SN1 is the more favorable pathway. SN1 is the more favorable compare with the SN2. Compare with the SN2. So why? Because of this is the easily formation of the intermediate. Give the intermediate very easily. That means the 6 is converted into 5 very easily. Here in SN2, 6 is converted into 7. This is somewhat very difficulty is there. So based on that, we can discuss about that means the factor affecting the acid hydrolysis reaction. So some different factors are there. In the all factors we can discuss means the give the priority is the what? SN means SN1 is a more preferable pathway compared to the SN2 pathway. So now we have discussed about the SN1 CV mechanism. SN1 CV. This is nothing about what? Base hydrolysis reaction. This is what? Base hydrolysis reaction. Base. That means in this reaction is undergoes to the what? Basic medium. This reaction undergoes to the what? Basic medium. Okay. So SN1 CV reaction mechanism or SN1 CV pathway. SN1 CV pathway. So what is the reaction here involved? So some basic points are there. Those metal complex are undergoes to the SN1 CV pathway. Some basic points are required. Okay. That means so some metal complexes are undergoes to the SN1 CV mechanism. 1 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 CV So some basic points are required. What is the point? The main point is the first point is the in those metal complex, that metal complex are contain minimum one acidic proton ligand is contain minimum one acidic proton ligand. Okay, that means in the metal is bind with the 6 ligands are there, no, 6 ligands, the formation of Ml6 complex. So in these 6 ligands, okay, minimum one ligand is contain the what, given the acidic proton ligand like ammonia, NH3. This is give what, acidic proton. That means that is converted into the amide. Okay, NH2 minus ga convert అవుతుంది. At the same time, ethylene diamine. So this type of ligands are given what, acidic proton. Okay, so this type of complex, those metal complex are contain acidic proton ligand, acidic protonic ligand. That type of complex are undergoes to the SN1 CV. Which medium? In the basic medium. That is known as what? As base hydrolysis reaction. That is known as what? Base hydrolysis reaction. So now we have discussed about the one complex. Which complex? Same. In the last class we have discussed about the complex. No, same complex are involved in the base hydrolysis also. What is the complex? CO NH3 5Cl. What is the name of this complex? Pentamine chlorocobalt complex. What is the complex? Pentamine chlorocobalt complex. In this pentamine chlorocobalt complex are also undergoes to the SN1 CV pathway. Are also undergo to the SN1 CV reaction mechanism. SN1 CV reaction mechanism. So here total 6 ligands are there. 5 are ammonia ligand is there, 1 is the chlorine ligand is there. Both are ligand. 5 plus 1 is how much? 6 ligand. Okay. So in this complex are contained 5 acidic protonic ligand are contained. How many is there? 5. We are required how much? Only one ligand. Minimum one ligand is contained the acidic protonic ligand. Please go to the mute. Okay, so here 6 ligands are there, 5 ammonia ligand, 1 is the chlorine ligand. So 5 ammonia ligands. That means each ammonia is converted into the amide NH2 minus and loss of one proton. So this type of ligands are contain the metal complex. That metal complex is undergoes to the what? SN1 CV pathway. That molecules are undergoes the which pathway? SN1 CV pathway. Okay. Now we are discuss about the mechanism. So just wait. I will put that page. Just wait. So now the SN1 CV pathway, we are discuss about that. So in that reaction is the undergoes to the 3-step mechanism is there. What is the mechanism? 3-step mechanism. So what is the means step 1, step 2, step 3. So in the step 1, what happened in the step 1 mechanism is what? This is the complex. Which complex? Pentamine chlorocobalt complex. Pentamine chlorocobalt complex. So in this complex is by react with the base. That is what? Basic medium is the hydroxide ion. React with the hydroxide ion. And the formation of this complex. Okay. The formation of this complex. What is the name of that complex? I will explain that. Okay. So here what? 5 ammonia ligands are there. How many is there? 5 ammonia ligands are there. One ammonia ligand is bind with the hydroxide ion. Bind with the hydroxide ion. And the formation of what? NH2 amide plus H2O molecule is formed. H2O molecule is formed. So this amide is acting as a conjugated base. This amide is acting as a conjugated base. So now here you can observe here. This is the conjugated base. Okay. What happened here? 5 ammonia ligands are there. So here 4 and 1 ammonia is converted into the amide. 1 ammonia is converted into the amide. NH3 4. You observe here. Confused? Okay. So here NH3 4 and NH2. NH3 4 and NH2Cl. In this complex is acting as a what? Conjugated base. That is what? Acting as a conjugated base. Okay. And loss of water molecule. Loss of water molecule. That is acting as a conjugated acid. That is acting as a conjugated acid. This is what? Step 1. What is the step 1? So the complex. Those complex are contain the acidic proton ligand. Those complex are contain the acidic proton ligand. That complex is bind with the hydroxide ion. That complex is bind with the hydroxide ion. So one of the ligand is loss of acidic proton. One of the ligand is loss of acidic proton and convert into the conjugated acid. Convert into the conjugated acid. Those ligand is loss of acidic proton. That ligand is acting as a conjugated base. Okay, that ligand is acting as a conjugated base. So that ligand is acting as conjugated base. The complex what? Conjugated base complex. The complex what? Conjugated base complex. This is nothing about what? Step 1. This is nothing about what? Step 1. Okay. So in this step is not involving in the rate determining step. This is not a RDS. This is not a RDS. Okay. Then now we are discussing about the step 2. Okay. Now discuss about the step 2. What is the step 2? So in that conjugated base complex, okay, that is loss of one ligand. That is loss of one ligand. That means what? For example, CO, NH3 4, NH2 Cl. This is the 6 coordinate complex. In this complex, what? Loss of one ligand and the formation of what? Loss of one ligand and the formation of CO, NH3 4, NH2. Loss of Cl minus. Loss of Cl minus. So the 6 coordinate is converted into 5 coordinate. Okay. This is what? Slow step. This is what? Slow step. And rate determining step. What? Rate determining step. So in this step is involving the rate constant is involve the what? This is the rate constant. Okay. K is equal to the concentration of the conjugated base and that is the product and reactant. Product and reactant. So here in the rate constant are involved the only this conjugated base complex are only one molecule are involved. That only one complex are involved. Which complex that? Those complex are acting as a conjugated base complex. Those complex are acting as a conjugated base complex. That is involved in the rate determining step. That is involved the rate determining step. Okay. So that's mean conjugated base. Only one molecule. Which molecule that? This is the molecule. Conjugated base molecule. This is what? Conjugated base molecule. How many molecules are involved? One molecule. What is the reaction? Nucleophilic substitution reaction. What is the name of reaction? SN1 CV. What is the name of reaction? SN1 CV. Conjugated base, unimolecular, nucleophilic substitution reaction. Conjugated base, unimolecular, nucleophilic substitution reaction. the conjugated base, the intermediate complex. The conjugated is found the intermediate. In that intermediate complex are involved the rate determining step or the rate of the reaction are involved in that intermediate complex. Okay, so that is the rate determining step or slow step. Rate determining step or slow step. Okay, so that is the what SN1 CV pathway. SN1 CV pathway. This is the step 2. What is the step 2? The 6 coordinate complex is converted into 5 coordinate complex. Step 2, 6 is converted into what? 5. That is called what? Dissociation mechanism. 6 converted into 5. Again, the 5 converted into the 6. This is which type of reaction? Dissociation reaction or SN1 pathway. Okay. In the rate constant are involved what? Conjugated base. So what is the name of reaction? Conjugated base, unimolecular nucleophilic substitution reaction. Unimolecular nucleophilic substitution reaction. Then step 3. We discuss about the step 3. What is the step 3? What happened here? The 5 coordinate complex. That means CO, NH3, 4, NH2. This is what? 5 coordinate complex. So in this 5 coordinate complex is react with the, in the step 1 or releasing what? Conjugated acid are there, no? In this conjugated acid, here involve the reaction. The conjugated acid is involved the reaction. So in this conjugated acid or undergoes the hydrolysis and the convert into H plus OH minus, H plus OH minus. So this H plus ion again react with the NH2 and the formation of what? NH3. That means the amide ion again convert into the ammonia, and this hydroxide ion is inside the coordination sphere. Okay, that means what is the product obtained here? CO, NH3 5, NH3 5, OH. The replace of or substitute of Cl by hydroxide ion. What is the first step? Pentamine chlorocobalt complex is converted into the pentamine hydroxo complex are contained. So the formation of pentamine hydroxo complex. Okay, this is what undergoes the which pathway? SN2 pathway. SN2 pathway. This is the acting as a conjugated acid. This conjugated acid is again undergoes to the hydrolysis. Again undergoes to the hydrolysis reaction. Again undergoes to the hydrolysis reaction. Okay, that means this undergoes hydrolysis, the convert into H plus ion and OH minus ion. Okay, this H plus ion again bind with the amide ion. Amide undi kada, NH2 undi kada, danto bind avutundi. Adi NH3 ga convert ayipotundi. Again, that is the NH3 5 pentamine ga vachestundi. Retain malli. Okay, so this hydroxide ion is inside the coordination sphere lo ellipotundi. That is what? Base. Okay, this reaction is undergoes the which medium? Basic medium. That is called what? Base hydrolysis reaction. That is called what? Base hydrolysis reaction. Okay, so now here we can observe one point is that this is the so the reactant, this is involved the base. Okay, K is equal to complex base. Okay, the conjugated base are involved the rate determining step. Conjugated base, that is the unimolecular nucleophilic conjugated base reaction. Okay, this is a very important. These 3 reaction mechanisms, one is given the examination compulsory question. Okay, so in this reaction also pictorial representation is there. I will show that pictorial representation. Okay, this is the mechanism of that. This SN1 CV pathway is involved the what? 3 steps. Okay, involve the 3-step mechanism. So you observe here. Step 2. So step 1, the convert into the conjugated base. Okay. Step 2 what? Loss of Cl. Loss of Cl. You know, so you can observe here. Okay, this is the NH2 conjugated base. Ammonia. 4 ammonias. Cl is there. So This in the rate determining step or slow step what? Loss of Cl and convert into the what? 5 coordinate complex. Convert into the 5 coordinate complex. 6 is converted into 5. That is called what? Dissociation. That is called what? Dissociation mechanism. That is called what? Dissociation mechanism. Okay. Next, step 3. In that 5 coordinate conjugated base complex, observe here. In that 5 coordinate conjugated base complex is react with the water molecule. So this water molecule is released from which step? Step 1. This water molecule released, that is conjugated acid అని చెప్పాను కదా, అక్కడ రిలీజ్ అయిన వాటర్ మాలిక్యూల్ ఇక్కడ again involved. Then this is undergoes the hydrolysis, convert into H plus OH minus ion. H plus OH minus ion. This H plus is bind with the amide NH2 minus ligand, and OH bind with the means insert the coordination sphere. Insert the coordination sphere. Okay, like this. Okay, so this is what, this is a fast step. Step 1 also fast step. This is the slow step. Step 2 is the slow step. That is the rate determining step. Rate determining step. In that rate determining step are involved the conjugated base. Conjugated base. Okay, conjugated base complex are involved. So this is nothing about SN1 CV pathway. This is a very, very important. Now we will show the pictorial representation of that. Okay, just wait. Wait a minute. So this is the pictorial representation of SN1 CV pathway. Pictorial representation. That means diagrammatically. You can explain the diagrammatically or pictorial representation of that. Okay, you can observe here. SN1 CV pathway or undergoes the in this manner. Which manner? In this manner. Okay, what happened here? So the first 6 coordinate complex. Okay, the 6 coordinates complex, that is the fast step. That is the fast step. Here involve the hydroxide ion. That means base. Okay, one of the ammonia ligand is loss of 1 proton. One of the ammonia ligand is loss of 1 proton. In that proton and the ligand, which ligand? Hydroxide ion. Both are connect and the formation of water molecule. Loss of water molecule. This water molecule is acting as a conjugated acid. This is involved the last step. Third step are involved the water molecule is there, no? A water molecule release in a water molecule release out involve avutundi. Okay, so in the first step what happened? The complex pentamine chlorocobalt complex is converted into the conjugated base complex. Is converted into the conjugated base complex. Okay, so here NH2 is there. NH2. This is what? Amide conjugated base. That is what? Conjugated base. Okay, so here step 2. In the step 2 what happened? So here this is the slow, here to here the converted conjugated base. In this conjugated base or loss of 1 Cl ligand, loss of 1 Cl ligand, and the convert into what? Trigonal bipyramidal geometry complex. Trigonal bipyramidal geometry. Okay, loss of Cl. Okay, Cl loss avutundi. That is what? Outgoing ligand. Cl is what? Outgoing ligand. Okay, so in the here amide ion is there. NH2 ion undi ikkada. Okay, so this is the intermediate. This is the intermediate complex. So this is the 6 coordination is converted into the 5 coordination. What happened here? Dissociation is takes place. What is the type of reaction? Dissociation mechanism. Dissociation mechanism. So this is the slow step and rate determining step. Slow step and rate determining step. Okay, so in this step 6 is converted into the 5. Again this 5 react with the H2O, react with the H2O. That is obtained from where? In the step 1, release in the water molecule. Adi ikkada involve avutundi. So in that water molecule or undergoes the hydrolysis and the formation of H plus OH minus ion. This H plus ion again bind with the NH2. Okay, rearrangement avutundi. NH2 bind avutundi and the formation transfer the proton, transfer the H plus, transfer the H plus. Water molecule is transfer the H plus and bind with the amide ion and the convert into the this complex. 6 coordinate complex is convert. This is what pictorial representation.
Once again represent cheyara sir pictorial. Once again cheppara sir mechanism.
Okay. So this is the pictorial representation. Here name ledamma. So the 6 coordinate ikkada emundi oka ammonia ligand, any 5 ammonia ligands are there. How many is there? 5 ammonia ligands. In that 5 ammonia ligands, any one ligand is loss of 1 proton. Any one ligand. ఆ 5 లో ఏదో ఒకటి ఒక ప్రోటాన్ ని లాస్ అవుతుంది. సో ఆ లాస్ అయిన ప్రోటాన్, అమోనియా లిగండ్ లాస్ అయిన ప్రోటాన్ అండ్ ఇక్కడ OH హైడ్రాక్సైడ్ అయాన్ కదా, OH మైనస్ అయాన్ ఇన్వాల్వ్ అవుతుంది రియాక్షన్ లో. ఓకే, అండ్ ద ఫార్మేషన్ ఆఫ్ వాటర్ మాలిక్యూల్, ఫార్మేషన్ ఆఫ్ ద వాటర్ మాలిక్యూల్ ఫార్మ్ అయింది చూడండి, బయటకు వచ్చేసింది. దెన్ ఇన్ దిస్ NH3 loss of 1 proton, that is converted into the NH2, that is convert the NH2. So that is what conjugated base. This is acting as a conjugated base. Okay, so here this is the conjugated base complex. This is the conjugated base complex. So in this complex are involved the rate determining step or rate of reaction. In this step, in this conjugated base complex is involved the rate of reaction. That means this is the SN1 CV pathway. Okay, so in this complex, which complex? Conjugated base complex. Conjugated base complex is loss of 1 ligand. Loss of 1 ligand. Which ligand? Chlorine ligand. That is what? Outgoing ligand. That is what? Outgoing ligand. That means one bond is a dissociation is takes place. ఒక బాండ్ డిసోసియేషన్ అయిపోతుంది, Cl బయటికి వెళ్ళిపోతుంది. ఓకే, దెన్ ద 6 అంటే మీన్స్ దిస్ ఇస్ ద octahedral. The octahedral geometry is converted into the trigonal bipyramidal geometry. This is a formation of very easily, not difficult. అదే octahedral PVP గా కన్వర్ట్ కావాలంటే కొంచెం డిఫికల్ట్. 6 is converted into the 7, that is somewhat difficult. Here there is no difficulties there. ఒక లిగండ్ లాస్ అయిపోతుంది, లాస్ ఆఫ్ 1 ligand and the convert into what? Trigonal bipyramidal geometry. Trigonal bipyramidal geometry. Okay, in this intermediate complex, this is what? Intermediate complex. Okay, this 5 coordinate complex what? Intermediate complex. So in that intermediate complex is react with the water molecule, is react with the water molecule. This water molecule released from here, release ayindi kada, ikkada release the water molecule here, that is involve, ikkada involve avutundi and occupy 1 coordination sphere. Occupy 1 possible is there now, 5 kada, 5 6 avutundi. Then this is the imide, ikkada emundi NH2 ion is there, NH2 is there. So 1 hydrogen transfer అయిపోతుంది. That means H2O again undergoes hydrolysis, the formation of H plus OH minus. H plus దేంతో amide తో bind అవుతుంది, OH insert అవుతుంది, rearrangement takes place. Rearrangement that is again convert into the octahedral. Okay, octahedral is converted into the trigonal bipyramidal, again that is converted into the octahedral. This is what this pathway, in this reaction undergoes this pathway. 6 is converted into 5, 6 is converted into 5, 5 is converted into again 6. Okay, this is what? Dissociation mechanism. This is what? Dissociation mechanism. Dissociation pathway or SN1 CV pathway. SN1 CV pathway. This is nothing about what? SN1 CV pathway. Okay, so this is a base hydrolysis. Basic medium lo jarugutundi. Here there is no SN2 is not possible here. Okay, so only SN1 is possible. Next, another type of reaction are there అని చెప్పాను కదా, total 4 types అని చెప్పాను కదా. the substitution reaction. So this is also very important. This type also very important. What is that? Substitution reaction without breaking metal ligand bond. You can observe here the heading. Okay, underline heading undi kada chudandi. Substitution reaction without breaking metal ligand bond. Without breaking a metal ligand bond. So in the previously we can discuss about how many mechanisms? 3. Okay. SN1 we have discussed about, SN2, and we have discussed about SN1 CV also. SN1 CV also. So in the SN1 association, the dissociation takes place. SN2 association takes place. That means here breakage of bond. SN1 లో ఏమైంది 6 5 అయింది. Dissociation లో ఏమైంది? Dissociation 6 is converted into 5. Association 6 is converted into 7. Okay, yeah, dissociation bond breaking is take place. Association bond making is take place. SN1 CV also bond dissociation. Okay, that means in these 3 reactions we can observe dissociate the bond or associate the bond, breaking of bond or making of bond. But in this type of reaction, now discuss about the type of reaction that is not break the bond, not break the metal ligand bond. Without breaking metal ligand bond, heading is there. Without breaking metal ligand bond, the substitution reaction is possible. The substitution reaction is possible. So now we are discussing about that. This is also very important for your examination point of view. These 4 are very important. Okay. So without breaking metal ligand bond, without breaking a metal ligand bond. So here, what is the complex is there? Pentamine cobalt carbonato complex. What is the complex? Pentamine cobalt carbonato complex. So this is a complex. Okay, this is complex కనిపిస్తుంది కదా స్టార్ మార్క్ పక్కన. pentamine carbonato cobalt carbonato complex. In that cobalt carbonato complex are undergoes the reaction with hydronium ion H3O plus ion to react అవుతుంది. 2 moles of hydronium ion. So here in that hydronium ion we can indicate the what is the isotope of oxygen. Okay, isotope of oxygen H3O పైన plus 18 ఉంది చూడండి H3O. So isotope of oxygen, that means indicate without breaking. This is not involve the bond formation. This oxygen is not involve the bond formation. That means in that carbonate bond is not a break. The carbonate lo una bond is not a break. Carbonate ion, what is the C minus. Okay, CO3 minus 2 carbonate ion. Okay, so in this oxygen is bind with the metal ki oxygen bind అవుతుంది. Okay, so this bond is not break. ఈ బాండ్ అనేది బ్రేక్ కాదు. మెటల్ కి ఆక్సిజన్ కి మధ్య ఉన్న ఈ బాండ్ బ్రేక్ కాదు. ఓకే, దట్ మీన్స్ వాట్? వితౌట్ బ్రేకింగ్ మెటల్ లిగెండ్ బాండ్, వితౌట్ బ్రేకింగ్ మెటల్ లిగెండ్ బాండ్ ఈ బాండ్ బ్రేక్ అవుతుంది. ఓకే, ఇక్కడ ఈ బాండ్ బ్రేక్ అవుతుంది, ఈ బాండ్ బ్రేక్ కాదు. మెటల్ లిగెండ్, కార్బన్ is the ligand is bind with the metal. Okay, which atom is bind with the metal? One of the oxygen is bind with the metal. Okay, this bond is not break, okay. So the formation of the complex and the substitution also possible. So this is a normal oxygen anukunte. So it involve the hydronium ion is there, no? In that hydronium ion is the isotope ga anukunte. This isotope ga బయటికి వెళ్ళిపోతుందని అర్థం. దాన్ని చూద్దాం ఇప్పుడు mechanism. We can discuss about the mechanism. Okay, without simple mechanism there only, then explanation also is there. I will send the material also after complete the class or after complete the lesson in the group. Okay, don't worry about that. So here what, this is the complex. Okay, pentamine carbonato cobalt carbonato complex is converted into the pentamine aqua complex. Okay, so here carbonate to CO2 ga బయటికి వెళ్ళిపోతుంది. At the same time aqua complex form అవుతుంది. The formation of the aqua complex ఇక్కడ మీరు అబ్జర్వ్ చేయండి. Okay, you can observe here This is the isotope 18. Okay, H3O plus. H3O plus. This is the what? 18. This is okay. Hydrogen in the convert into the water molecule ga బయటికి వెళ్ళిపోతుంది. That means ఈ isotope మళ్ళీ isotope గా బయటికి వెళ్ళిపోతుంది చూడు ఇక్కడ. The isotope again outgoing the isotope. That means in this oxygen is not involved the bond formation. Okay, link is not there. Just wait.
Sir, how can I join in the group, sir? Telegram. Actually, I got a mail that I clicked that one, but that is not working, sir. That's why
you can download the Zoom app only in that app. Password is there. At the same time, ID also is there. You can enter that password and ID. You can join the class. Simple thing. Already there in a class. Hello.
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 Sir, is there any Telegram group, sir, for M.Sc. first year chemistry students, sir?
There is no Telegram group. Only WhatsApp group is there.
WhatsApp group. Okay, sir. How can I join that group, sir?
So in that WhatsApp group, send the link. You can go to in that link. Also, the password is there and ID also is there. You enter the ID and password. We can enter, means join the group Zoom app. Okay. So here, without breaking metal ligand bond, you can observe that. Okay, చూడండి ఇక్కడ step 1. This is the also undergoes the 3 steps. So in the first step, what happened? Step 1, in this pentaamine carbonato complex is react with the hydronium ion. So in that hydronium ion is attack the one of the oxygen. That oxygen is bind with the metal. This hydronium ion ఎక్కడ బైండ్ అయింది? మెటల్ పక్కన ఉన్న ఆక్సిజన్ ఉంది కదా, ఆ ఆక్సిజన్ తో బైండ్ అయింది. This is a O18 isotope. This is the normal oxygen. Metal is contain the normal oxygen. That oxygen is coming from carbonate ion. Okay, this is hydronium ion. Okay, that is the formation of intermediate complex. This is the intermediate complex. So in that intermediate complex, what happened? Loss of water molecule. In that intermediate complex is loss of what? Water molecule. Loss of this water molecule. Okay, this is what slow step and rate determining step. Slow step and rate determining step at the same time. That is the loss of CO2 also. Okay, so here what? That is, there is no break the bond. Metal ligand bond is not break. This bond is not break. Okay, so where the bond break, the CO2 is lost. At the same time, water molecule also lost. So after loss of CO2 and the water molecule, okay, that is the formation of the complex. That is what? Hydroxo complex. Okay, that is the slow step and rate determining step. Okay, then you can observe the step 3. Okay, so once read that reaction mechanism, you can easily understand. So here the formation of what? Hydroxo complex. Hydroxo complex form avutundi. Loss of CO2 and water molecule and the formation of what? Hydroxo complex. So in that hydroxo complex again react with the hydronium ion. So in the reaction, how many hydronium ions are involved? 2 hydronium ions are involved. Round involve in the 2H3O plus. Round involve avutundi. So ఒకటి ఇక్కడ ఇన్వాల్వ్ అయింది. One is involve step 1. Okay, the second one is involve the step 3. The second one is involve the step 3. They involve the hydronium ion. This hydronium ion what H3O plus is give the H plus water molecule ga బయటికి వెళ్ళిపోతుంది. This H plus is bind with the hydroxide ion. H plus ఎక్కడ bind అవుతుంది? దీనికి bind అవుతుంది OH కి. And the formation of aqua complex. That is the fast step. That is the what fast step చూడండి ఇక్కడ. Okay, this is a without breaking metal ligand bond. Very simple reaction. Okay, not a complicated reaction, very simple. That is the formation of aqua complex. Okay, the loss of water molecule H3O ఉంది కదా ఇక్కడ. ఈ H3O ఏమైంది ఒక H ప్లస్ ని ఇచ్చేసింది దేనికి హైడ్రాక్సైడ్ అయాన్ కి ఇచ్చింది. సో దీని హైడ్రాక్సైడ్ అయాన్ is get or accept the proton. That proton is coming from where? Hydronium ion. Okay, hydronium ion ఇచ్చే proton ని hydroxide ion తీసుకుంటుంది. At the same time the loss of water molecule. At the same time that is the loss of water molecule. That is the isotope. This water molecule are contain what? 18. Oxygen 18 is the isotope. Okay, in that isotope again loss of isotope ga బయటికి వెళ్ళిపోతుంది. Okay, this mechanism is without breaking a metal ligand bond. The substitution reaction is followed or forward without breaking a metal ligand bond. Without breaking metal ligand bond. So here we are discussing about the 4 types of mechanisms. We discuss about the 4 types of mechanism. One is the SN1, second one is the SN2, and the third one is the SN1 CV, and the fourth one is the without breaking metal ligand bond. Without breaking metal ligand bond. Okay, this is also formation of the complex. This also undergoes the formation of complex undergoes the one type of pathway. Undergoes the one type of pathway. The pathway is nothing but what? A mechanism. The pathway is nothing about what? Mechanism. Okay, this is the 4 types of reaction mechanisms are involved in the which complex? 6 coordinate complex. Which complex? 6 coordinate complex. Okay, then 4 coordinate complex also is there. 4 coordinate complex also the involve the means what substitution reaction. So we discuss about the 4 coordinate complex, and some reactions are transfer the electrons from one complex to another complex. The transfer of reaction, the transfer of electron from one complex to another complex, that is called what? Electron transfer reaction. Electron transfer reaction. Now that is we are discussing about the electron transfer reaction and the 4 coordinate complex. The substitution
Hello?
reaction.
Hello, sir.
Ah.
Once tell third and fourth, sir. Name of the third and fourth mechanism. 4 are there, no? 6 coordinate compounds. 4 mechanisms. First is SN1 reaction. Then once repeat the name, sir. I joined late, sir. Just third, fourth.
SN1 is nothing but a dissociation mechanism. Unimolecular
Okay,
nucleophilic
sir.
substitution reaction.
Okay, sir.
SN2 is the association mechanism.
Okay.
Bimolecular nucleophilic substitution reaction.
Okay, okay.
And the
Third,
third
fourth,
one is
sir.
the SN1 CV. That means conjugated base. CV is nothing but conjugated base.
Okay, okay.
Unimolecular nucleophilic substitution reaction.
Okay, sir.
And the fourth one is the without breaking metal ligand bond. Substitution reaction is followed by without breaking metal ligand bond. The name is not there. Without breaking metal ligand bond.
Okay, okay. Is it SN1 or SN2, sir? Simply without
That is
breaking.
also like that SN1 type, but metal ligand bond is not break.
Not
that
break.
is not comes the SN1, SN2. That is
Thank you,
separate
sir.
type of reaction. Separate reaction.
Okay, thank you, sir.
Without
Thank
breaking,
you.
breaking takes place. That is SN1 or SN2. No. So here
Okay,
without
okay.
breaking. Okay.
Thank
So
you, sir.
these 4 types of reaction are undergoes to the 6 coordinate complex. And the octahedral complex are undergoes the this 4 type of reactions. Okay.
Okay,
now
thank you, sir.
4 coordinate complex also is there. 4 coordinate complex, and in that 4 coordinate complex, what is the geometry of that in general? What is the geometry of 4 coordinate complex? 6 is nothing but octahedral. 6 is nothing but octahedral. 4 is nothing but coordination number 4. What is the possible geometry?
Tetrahedral, square.
Number 4 is equal
Square
to
planar. Square planar or tetrahedral.
is a square planar and a tetrahedral. Square planar and a tetrahedral. So here we have discussed about the substitution reaction of square planar complex. The substitution reaction of square planar complex. Okay. So that is this is also very important mechanism. This is also very important mechanism. So first, which type of metals are the formation of square planar complex? Which type of metals? In general, metal is bind with the 4 ligands. The formation of what? Ml4 complex. The formation of what? Ml4 complex. This Ml4 complex are possible 2 types of geometries. 2 types of geometries. One is the square planar geometry. The second one is the tetrahedral geometry. In the square planar geometry, what is the hybridization? We can find out the
sp3
hybridization, then we can explain the geometry. We are find out the hybridization. Based on the hybridization, we can discuss or we can find out the geometry. So in the square planar geometry, what is the hybridization?
DSP2.
DSP2 is the hybridization. Okay. One of the d orbital are involved the hybridization. That is means the geometry is in the 4 coordinate complex. One of the d orbital is involved the hybridization. That is give the geometry is a square planar geometry. What is the hybridization of tetrahedral geometry? sp3. What is the okay? sp3 hybridization. sp3 hybridization. Okay, that means metal. In this metal is nothing but different types of metals are there. That metal, some metals are the formation of tetrahedral complex, some are the formation of square planar complex. Which metals are the formation of square planar complex? Which metals are the formation of tetrahedral complex? Okay, so which metals are the formation of square planar complex? Those metals are contain almost fulfill of the d electron, almost fulfill. That means those metals are contained in the d orbital d8 or d9 configuration. d8 or d9 configuration. So this type of metals in general, this type of metals are the formation of square planar complex, or the formation of square planar.
అది రాకపోతే నేను చేసి కొట్టేస్తున్నా అదంటే నాకే క్లాస్ విన్నేస్తుంది.
So now discuss about that.
ఏమ్మా తింటావా తినవా ఏటి చెప్పు నాకు. నేను అదా తినిపిస్తాను.
మ్యూట్ లో వెళ్ళండి అమ్మా కొంచెం. Just wait, I will share that. Just wait అమ్మా, పేపర్ దొరకట్లేదు అది. చదవండి. Okay, so the substitution reaction in square planar complex. Substitution reaction in square planar complex. So which metals are the formation of square planar complex? ఇక్కడ చూడండి, metals such as rhodium, iridium, platinum, palladium, silver, aurum. Okay, all of these metals. Okay, this type of metals are the formation of what? Square planar complex. You can observe these metals electron configuration almost fulfill ga untai. Electrons are almost fulfill ga ఉంటాయి. Which elements? Rhodium, iridium, platinum, palladium, silver, aurum. Okay, all of them with form square planar complex. Okay, next, rhodium and iridium undergoes the oxidation reaction and also change their geometry. Hence, these are not perfect. Okay, refer to the study of substitution reaction. That means rhodium and iridium is the formation of square planar complex that is easily undergoes the oxidation reaction lo participate avutundi. That means we are not explain the reaction mechanism of this complex. Okay, the formation of square planar, but we are not discuss manam dani explain chesenta properties daniki undavu. Okay, next, which element? Platinum and palladium also the formation of square planar complex. Platinum and palladium also the formation of square planar complex. Okay, the palladium square planar complex, PD. Okay, the palladium square planar complex is 10 to the power of 5 times faster than that of platinum complex. Okay, the reaction and that is undergoes the substitution reaction. Palladium complex, palladium square planar complex are undergoes the substitution reaction. The reactivity is 10 to the power of 5 times faster than that of the platinum. 10 to the power of 5 times. That means we are not seeing that mechanism. Okay, reactant is easily or fastly, not easily, reactant is fastly converted into the product. Okay, here in the intermediate we are not observe their mechanism, we are not study their mechanism. Okay, so in the octahedral complex SN1 undi, what happened? SN1 6 is converted into the 5, again 6 converted నేను చెప్తున్నాను మీకు. Okay, that means we are observe the intermediate complex, we are observe the intermediate complex for the SN1. SN2 also same, 6 is converted into the 7, again convert into the 6. Okay, itla మనం in the intermediate we can observe, we can study the complex. Okay, complex nature, the 5 or 6 or 7 ani itla. This type of explanation are not there here. Why? Because of the reaction mechanism is 10 to the power of 5 times faster than that of platinum. Okay, platinum is formed at the same time palladium is formed. The substitution reaction is 10 to the power of 5 times faster than that of 10 to the power of 5 times faster or greater than that of the platinum complex. That means the palladium is the formation of square planar complex, that is no doubt. In that square planar complex or undergoes to the substitution reaction. Which substitution reaction? Nucleophilic substitution reaction. Which reaction? Nucleophilic substitution reaction. In that reaction,
reason platinum కంటే palladium అనేది
కాంప్లెక్స్ స్టేబుల్ గా ఉంటాయి కాబట్టి there is no reasons.
అంటే ఎలక్ట్రాన్స్ బట్టి చెప్తామా, కాన్ఫిగరేషన్ బట్టి చెప్తామా, వీక్ ఫీల్ స్ట్రాంగ్ ఫీల్, రీజన్ ఏది ఉంటుంది సార్?
దట్ ఈస్ ద స్టెబిలిటీ దట్ ఈస్ బేస్డ్ ఆన్
palladium ఎలా స్టెబిలిటీ ఎలా?
సో platinum is the platinum is the less stable complex compared with the palladium. Okay, so that's why platinum is undergoes the substitution reaction, the formation of different complexes after involve the substitution reaction, that is the formation of stable complex. Okay, palladium is a that is already stable complex. For example, we can create some conditions and move the substitution reaction. That reaction is undergoes very fastly. How much? That is the 10 to the power of 5 times faster than that of platinum. Okay, in the platinum is goes the slow motion, reaction mechanism is slow motion. Palladium is undergoes the fast motion. Okay, that is immediately the formation of product. Reactant is immediately the formation of product. Okay, that is very fastly within fraction of seconds. Okay, and we can compare another metal also is there. Which metal? We can compare the platinum and nickel also. Okay, we can compare the platinum and nickel. We can compare the platinum and nickel. Platinum also the formation of square planar complex. At the same time, nickel also the formation of square planar complex. Nickel also the formation of square planar complex. Okay. In this complex, substitution reaction is nickel substitution reaction is 10 to the power of 5 times, 10 to the power of 3 times faster than that of platinum complex. 10 to the power of 5, 3 times greater than or faster than that of platinum complex. That means here also in the nickel substitution reaction, also nickel square planar substitution reaction also, we are not means explain their mechanism. We are not explain their mechanism. That means we are not find out properly in the intermediate complex. We are not find out. That means that time of that much of time is not required. That much of time is not there. Immediately the intermediate is formed. Again convert to the product. Immediately, fraction of seconds. And this in this reaction mechanism is complete in the fraction of seconds. Okay. That means 10 to the power of 3 times. That means 1000 times is faster than that of platinum substitution reaction, nickel substitution reaction. You compare both reaction. Nickel is the almost 1000 times faster than that of 1000 times. 10 to the power of 3 is nothing but 1000. One are contain 3 zeros. That is what 10 to the power of 3. 1000 times greater than or faster than that of platinum. Okay. So now we are discuss about the substitution reaction of square planar complex is which metal is the suitable metal? Platinum is the suitable metal. Okay. So in general, in the d orbitals are contain almost fulfill of the electron. That means in general D8, D9 configuration metals are the formation of square planar complex. Okay. In that square planar complex are undergoes the substitution reaction is very fastly. Okay. Some reactions are undergoes the oxidation, some are undergoes the reduction. Okay. That type of reaction we are not explain their substitution reaction. Okay. The rhodium, iridium is there now. That is undergoes the reduction, sometimes oxidation. That means increase their oxidation number, increase or decrease. Okay. In that condition, increase or decrease, d orbital change the electron. That means we are not explain the substitution reaction of that metals. Okay. Some other metals are there. Platinum is there. Nickel is there. Palladium is there. Okay. These all are the formation of square planar complex. But their reactivity is some metals are very fast. Okay. In the palladium is 10 to the power of 5 times. Nickel 10 to the power of 3 times or faster than that of the platinum. That means what? We can observe or we can explain the substitution reaction of square planar complex is which is a suitable metal? Platinum is a suitable metal. Which is a metal? Platinum is the suitable metal. Okay. So now we discuss about that platinum metal substitution reaction. Okay. So here platinum is +2 state lo ఉంటుంది. Platinum is always contain the +2 state. Okay. Now discuss about that. So here the platinum is undergoes a substitution reaction, the very slow. That means we can observe the each and every step in the intermediate. Okay. That is the some trans effective series are there based on the ligands. Okay. The strength of the ligand. We can explain the applications of trans effect. We can explain the applications of trans effect. Applications are there. These are the very, very important. Write a note on trans effect and give their application. The examination frequently asking the question. Write a note on trans effect and give the application. So now we are discussing about that. So for example, platinum is contain the formation of 4 coordinate complex, that is the tetrachloroplatinum complex. Okay, in this platinum complex we can substitute the one of the Cl. One of the Cl is nothing but nucleophile. Platinum is the central atom. 4 corners are occupy 4 Cls. 4 corners are occupied what? 4 Cls. What is the geometry? Square planar geometry. What is the geometry? Square planar geometry. So here one of the Cl is substituted the another ligand. That is the incoming ligand. That is the incoming ligand. So here one series is there. Trans effective series is there. So here in this reaction mechanism, sometimes this is the formation of major product. Sometimes trans is the formation of major product. Sometimes cis is the major, or sometimes trans is the major. So that is depend on the strength of the ligand. That is depend on the strength of the ligand. That is known as the trans effect. That is known as the trans effect. And it means in the tetrachloroplatinum complex or tetraaminoplatinum complex are different types of ligands are there. The applications is there. Now we are discussing about their application and mechanism also is there. Okay, so now we'll discuss about that. So here this is a trans effect series is a very important. Okay, you can by heart this. Okay, we can buy that is the based on the this trans effect series. Based on this trans effect series, sometimes cis is the major. Major is nothing but the formation of more content. Sometimes trans is the major or stable. Okay, in general trans is the stable complex. Compare the cis. Trans is the major and stable complex. Compare with the cis. Compare with the cis. But here sometimes cis also major or cis also stable. That is can explain about what? Trans effect series. Okay, the trans effect series is there. That is the Cn minus is greater than C2H4 is greater than CO. That means carbonyl is greater than Tu, tertiary butyl. Okay, is greater than. That is called what? Trans effect series. And NO2 minus SCN thiocyanide. SCN thiocyanide. Okay, next what? I minus, Br minus, Cl minus, pyridine. Okay, and amine RNH2. Okay, amine RNH2, ammonia NH3, and OH minus H2O. Okay, you can compare here. All are greater than means the decreasing order. This is the decreasing the trans effect order. Decreasing the trans effect order. Cn to H2O. Cn to H2O. Cn cyanide nunchi H2O వరకు decrease the trans effect. Decrease the trans effect. That means Cn is bind with in a trans position is the stable complex. Okay, compare with the ethene C2H4 and compare with the CO carbonyl. Okay, based on that we can explain one application. That is the you can easily understand. So here observe here the what is the starting product here? Platinum tetrachloride is the starting material or reactant. Platinum or tetrachloroplatinum is the reactant. So in that reactant is react with the ammonia. That is ammonia is the what? Incoming ligand. Ammonia what? Incoming ligand. Okay, so here first ligand, first ammonia is enter into the in this coordination sphere. Enter into in this coordination sphere. So one of the Cl is outgoing. 4 Cls ఉన్నాయి కదా, ఏదో ఒకటి బయటికి పోతుంది. So that means in this ammonia any Cl ని eliminate చేయొచ్చు or substitute చేయొచ్చు. 4 probabilities are there. First step is there is no restrictions here. Why? Because of 4 Cls are there. The 4 Cls are similar bond length, similar bond energy, at the same time similar bond angle. Similar bond angle. The bond angle is same. The bond length is same. At the same time the bond strength also is same. The bond strength also is same. So the first incoming ligand is attack the or substitute the NaCl. Substitute the NaCl. So for example, ఇక్కడ Cl ని సబ్స్టిట్యూట్ చేసింది, ఇక్కడ substitute the this Cl, substitute the this Cl, and the loss of one Cl. Okay, Cl బయటికి పోయి ఇంకో ఒక NH3 వచ్చింది. This is the step 1. Step 2, the second incoming ammonia ligand, is ఏం చేస్తుంది? రెండో అమోనియా ligand వస్తుంది కదా, that is substitute in which place? Which place is nothing but this is the substituted ammonia, first ammonia, second ammonia కూడా వస్తుంది. అదేం చేస్తుంది? 3 chlorines are there. In that 3 chlorines, what happened? One is the opposite position, that means trans position is there. Remaining 2 is the cis position is there. అంతే కదా. ఇప్పుడు వచ్చే అమోనియాకి సెకండ్ ఇన్కమింగ్ లిగెండ్ ఆఫ్ అమోనియా అది ఎక్కడ పడితే అక్కడ పోదు. ఓకే, ఫస్ట్ ఈస్ ద 4 Cls ఉన్నాయి, ఏదో ఒక Cl ని సబ్స్టిట్యూట్ చేస్తుంది. అంటే ఫస్ట్ అమోనియాకి రిస్ట్రిక్షన్స్ ఏం లేదు, ఎక్కడైనా పోవచ్చు, అది ఏ Cl ని అయినా బయటికి పంపించవచ్చు. ఓకే, అండ్ సెకండ్ అమోనియా, that is follow some instructions, that is follow some rules. What is the rule? That is the two possibilities are there, or two positions are there. What is the positions? Cis position అంటే పక్కనే ఉన్న పొజిషన్ ఏమంటాం? దీన్ని మనం cis position అంటాం. And opposite position also is there, that is what? Trans position. This is what? Trans position. These two are what? Cis position. Okay, so the second incoming ligand is attack or substituted the which position is the suitable position? Both are possible. So sometimes one position is the major position, one is the minor position, or one position is the formation of stable complex, one position is the formation of less stable complex. That is can depend on the what? Trans effect series. Trans effect series. Now you can observe here, already chlorine is there, already platinum దగ్గర ఏమున్నాయి? Chlorines ఉన్నాయి. ఓకే, ఏది వస్తుంది? Which is the incoming ligand? Ammonia is the incoming ligand. Okay, what is the strength? What is the trans effect? Not strength. What is the trans effect? The trans effect is chlorine is greater than that of the ammonia. That means already chlorine is there, already unnai, one ammonia is there. So this ammonia is the less trans effective than chlorine. That means the incoming ligand is less trans effective than already attached ligand. The incoming, what is the point? The incoming ligand is less trans effective. Than already attached ligand. That means the second incoming ligand of ammonia is first, that is find out the suitable position or labile position. You can understand that the second incoming ligand, the strength is less. What is the strength? Trans effect is the less, not strength. The trans effect is the less, that is incoming ligand. So in that incoming ligand is find out 3 positions are there. Now ఈ 3 పొజిషన్ ఇక్కడ ఆల్రెడీ అమోనియా వచ్చింది. ఓకే, ఎన్ని పొజిషన్లు ఉన్నాయి? 3 పొజిషన్స్ ఉన్నాయి. ఇది ఒక పొజిషన్. హౌ మెనీ పొజిషన్స్ ఆర్ దేర్? 3 పొజిషన్స్. దిస్ ఈజ్ వన్ పొజిషన్. జస్ట్ వెయిట్. So this is one position, this is one position. Here already ammonia is there. Here what? Ammonia is there. This is the ammonia. Second ammonia vastundi. So these 3 positions, first that is find out the labile position. Labile is nothing but unstable position. Okay, the strength దీనికి తక్కువ, chlorine కంటే దీనికి తక్కువ కాబట్టి this is find out the which is the suitable position. The Cl cis position is the suitable position. Cis is the suitable position. Okay, why? Because of the strength is the less, the ట్రాన్స్ ఎఫెక్ట్ ఇస్ ద లెస్, ఇన్కమింగ్ లిగెండ్ యొక్క ట్రాన్స్ ఎఫెక్ట్ తక్కువ ఉంది కాబట్టి cis is the labile position, trans is the inert position, trans is the inert position. So inert position ని డిస్టర్బ్ చేయదు అది.
వన్ డౌట్ సార్, మీరు ఇప్పుడు చెప్పారు కదా సిస్ అండ్ ట్రాన్స్ ఫామ్ అయిందని. మీరు అక్కడ NH3 మాలిక్యూల్ ప్లేస్ లో ఎందుకు హై ఎనర్జీ ట్రాన్స్ ఎఫెక్టివ్ ఉన్నదే తీసుకుంటున్నారు? నార్మల్ గా దానికన్నా ఎక్కువ క్లోరిన్ కన్నా ఎక్కువ బేరియం ఉంది, అయోడిన్ ఉంది, ఇవెందుకు తీసుకోకూడదు?
తీసుకోవచ్చు.
మరి అప్పుడు లైగెండ్ ఎమిట్ అవుతున్నప్పుడు లెస్సర్ ఎఫెక్టివ్ ఉన్నది ఎమిట్ అవుతుందా, హైయర్ ఎఫెక్టివ్ ఉన్నది ఎమిట్ అవుతుందా?
అది కూడా చెప్తా. దట్ ఎగ్జాంపుల్ ఆల్సో ఇస్ దేర్. డిపెండ్ ఆన్ ద ట్రాన్స్ ఎఫెక్టివ్ లైగెండ్.
ఓకే,
వాట్ ఈస్ అవర్ పాయింట్? సిస్ ఫామ్ అవుతుందా ట్రాన్స్ ఫామ్ అవుతుందా చెప్పాలి. ఎనీ లైగెండ్, యూ టేక్ ఎనీ లైగెండ్, నాట్ ఓన్లీ దిస్ టూ లైగెండ్. ఇట్లా ఇవి రెండు తీసుకోవాలి రూల్ ఏం లేదు. యూ టేక్ ఎనీ లైగెండ్.
ఓకే,
దట్ ఈస్ వాట్ డిపెండ్ ఆన్ ద ట్రాన్స్ ఎఫెక్ట్ నేచర్ ఆఫ్ ఇన్కమింగ్ లిగెండ్ యొక్క నేచర్ పైన డిపెండ్ అయి ఉంటుంది కాంప్లెక్స్ ఫార్మేషన్ అనేది.
ఓకే సార్, ఆ కేసులో అయినా కూడా ఇప్పుడు NH3 అనేది లెస్ ట్రాన్స్ ఎఫెక్ట్ మోర్ దెన్ క్లోరిన్.
అవును.
అప్పుడు అమోనియా మరి క్లోరిన్ ఎలా ఎమిట్ అవుతుంది సార్? క్లోరిన్ అక్కడే ఉండాలి, అమోనియా మాత్రమే బయటికి ఎమిట్ అవ్వాలి కదా.
మనం సబ్స్టిట్యూట్ చేస్తున్నాం. యు ఆర్ గివ్ సమ్ కండిషన్స్. Conditions is a reaction possible. Any reaction is possible. You apply the conditions.
Okay.
We are not discuss about the strength of the ligand. Mana strength gurinchi maatladtale. Not discuss the strength.
Okay.
Discuss the trans or cis.
Okay.
Platinum is undergoes to the substitution reaction.
Okay.
That is due to means isomers.
Okay, sir.
Two isomers. One is the cis isomer, one is the trans isomer. So which isomer is the stable or which is the major? Major is nothing but equa form outundi. Which is the minor? That is depend on the incoming ligand. The trans effective nature of incoming ligand. Okay. So that example also came. Just wait. Adi kuda vastundi neeku.
Okay, sir. Now I understood.
Okay. Okay. So here the second incoming ligand is identify the labile position first. Which is the labile position? Cis is the labile position. Which is the labile position? Cis is the labile position. And the formation of what? Cis is the major complex. Cis is the major complex. Cis is the major. Platinum cis. Platinum 2 complex are formed. 2 ammonias are same side unnai. 2 ammonias are same side. Okay. Cis is the major. Okay. Next, you take another example. Discuss about the other example. Just wait. Inko paper pedtanu. So 11:30 వరకు ఉంటది క్లాస్. So after that you can join another class. Next example. So here what? Tetramine platinum complex. You can take the starting material what? Tetramine platinum complex. Tetramine. Previously you can take tetrachloro. Here tetramine. Okay. Tetramine platinum complex. You can take the reactant. So in that reactant, Cl is the incoming ligand. Cl is the incoming ligand. Ammonia is the outgoing ligand. Okay. Cl is a more trans effective ligand compared with the ammonia. Okay. So ఇక్కడ ఏంటిది? Cl వస్తుంది. ఇక్కడ ఇప్పుడు ఈ 4 కోఆర్డినేషన్ లో ఒక కోఆర్డినేషన్ ని బయటికి పంపించాలి. దేన్ని పంపిస్తుంది? That means all ammonias are bind with the platinum in the same manner. All ammonia ligands are bind with the platinum in same pattern. That means what? The bond angle is same, bond length is same, and the strength, bond strength also same. Bond energy antam, bond strength also same. Okay. But we can replace one Cl replace cheyali ante that is the replace any Cl denaina replace cheyochu. This Cl is replace any ammonia. So for example igo ikkada అమోనియాని సబ్స్టిట్యూట్ చేసింది. ఓకే. సో అక్కడ వీటి చేసింది, ఇక్కడ చేసింది, దాన్ని చూద్దాం. సో దట్ ఈస్ రిప్లేస్ దిస్ Cl. ఇక్కడ ఉన్న అమోనియా రిప్లేస్ చేసింది. That is the for platinum. Platinum. 4 ammonias are there. Okay, 4 ammonias. Enante ammonia anukondi. 4 ammonias are there. That is a square planar geometry. Okay, oka Cl vastundi bayat nunchi. One Cl is incoming. Okay, one of the ammonia ni bayatiki panpichindi. Deenni bayatiki panpichindi anukundam. Ikkada vachi Cl this ammonia ni eliminate chesi ikkada Cl కూర్చుంది వచ్చి. దేన్నైనా చేయొచ్చు. ఫస్ట్ Cl or substituted of any ammonia. First Cl is substitute of any ammonia. Okay, so this ammonia ni substitute chesindi Cl. Then the enter into the second ligand also. Second Cl కూడా వస్తుంది ఇప్పుడు. ఇది ఎక్కడ పోతది? This is attack which position?
Chlorine transposition also.
That is compare. This Cl వచ్చి అక్కడ చూస్తుంది. చూసి ఏం చేస్తుంది? How many positions are there? 3 positions are there. How many is there? 3 is there. Which is the labile position? That is first identify the labile position. That means which is the weak position. So these are less trans effective ligand. The incoming ligand is a more trans effective. The already attached ligand is the less trans effective. So the more trans effective ligand is enter. Okay, which is the labile position? Opposite is the labile position. Which is the labile position? Opposite is the labile position. Opposite. Okay, opposite nothing but trans is the labile position. Okay, the second incoming ligand attack here. The second incoming ligand attack which position? Okay, in this position, trans position la attack chestundi. That is attack the trans position. Okay, this is the incoming ligand. So here trans is the major product. Trans is the major product. This is the minor product. Okay, so this is what very important. This applications of trans effect you can observe here. Okay, in this complex here trans, both Cls are in which position? Trans positions. Both Cls are which position? Trans position. That means the position means the stability or the major or minor product is dependent on the trans effect of incoming ligand. The trans effect of incoming ligand. So based on that here different examples are there. You can observe here there are 2 different types of ligands in tetrachloroplatinum complex ఉంది. ఫస్ట్ ఏం వచ్చింది? అమోనియా వచ్చింది. You can observe this mechanism. Okay, which mechanism? This. ఇది చూడండి, tetrachloroplatinum is the reactant. అదే ఉండాలని రూల్ ఏమి, ఏదైనా పెట్టుకోవచ్చు. నువ్వు టెట్రాక్లోరో పెట్టుకోవచ్చు, టెట్రా ఐడో పెట్టుకోవచ్చు, టెట్రా బ్రోమో పెట్టుకోవచ్చు. యువర్ లైక్. ఓకే, ఇన్కమింగ్ లిగండ్ యొక్క స్ట్రెంత్ ని బట్టి దట్ ఈస్ సిస్ ట్రాన్స్ అనుకోవాలి. సో ఇక్కడ వన్ ఆఫ్ ద Cl ఈజ్ రిప్లేస్డ్ బై అమోనియా. సో ఇక్కడ అమోనియా ఇక్కడ వచ్చి కూర్చుంది. సెకండ్ ఇన్కమింగ్ లిగండ్ ఇస్ వాట్? NO2 మైనస్. Second incoming ligand what? NO2 minus. So that is identify the labile position first. So the second incoming ligand, already 2 ligands are there. To compare the trans effect, effective series. Okay, which is the suitable position? Labile position. Cis is the labile position. E ligand ki cis is the labile position. The formation of what? Cis product is formed. Okay, atla. Next, అదే లిగండ్ లో ఫస్ట్ NO2 వచ్చింది అనుకో, సేమ్ రియాక్షన్ రివర్స్. ఇక్కడ సెకండ్ వచ్చింది, సెకండ్ ఇన్కమింగ్ లిగండ్ ఇస్ ద NO2, ఫస్ట్ ఇస్ ద అమోనియా, సిస్ ఇస్ ద మేజర్. సేమ్ రియాక్షన్ ఫస్ట్ NO2 వచ్చింది, తర్వాత అమోనియా వచ్చింది. వాట్ ఈస్ ద trans is the major position. What is the position? Trans is the major. Ikkada cis is the major. Okay, this is nothing about the trans effect. This is nothing about the trans effect. So many examples are there. Okay, this is the very important question, compulsory question for your examination. This is a very important question. Okay, so this is nothing about the trans effect. Trans effect in their
Definition and applications, right?
Yes, definition and application very important.
Application.
Okay,
Okay, sir.
So enduku transposition is the major, cis is the major, and enduku that is the some theories are there. We can explain the substitution reaction of trans effect or square planar complex. Two theories are there. One theory is the polarization theory. One theory is the polarization theory. And that means their dipole moment, based on the dipole moment. One theory is the pi bond theory. Okay, we can explain the trans effect. We can explain the trans effect. Depend on the two theories are there. Two theories. One is the polarization theory.
Pi bond
theory. The second one is the pi bond theory. Second one is the pi bond theory. So this is theories can explain the next class. Okay.
Okay, sir.
So now we join the next class also is there. Okay.
Okay, sir.
Thank you all of you.
Thank you, please notes share कर दीजिए sir.
करते हैं.
Thank you, sir.
Last class కూడా మీ notes పంపించలేదు సార్.
सर लास्ट क्लास के भी नोट्स सेंड करते बोले थे सर.
नोट्स ग्रुप లో సెండ్ చేయండి సార్, పీడిఎఫ్ పర్సనల్ గా కాకుండా
లో సెండ్ చేయండి సార్.
హలో
So listen all of you. ఒక 15 minutes లేట్ అవుతుందంట ఆర్గానిక్ క్లాస్. ఓకే, హలో, ఒక 15 minutes లేట్ అవుతుందంట ఆర్గానిక్ క్లాస్. వెయిట్ చేయండి.
ఓకే సార్, నోట్ పీడిఎఫ్ సెండ్ చేయండి సార్ గ్రూప్ లో.
ఓకే,
హలో,
I will send complete PDF. I will send.
Notes కూడా send చేయండి sir.
After complete the chapter, I will send the full material, full PDF.
Okay.
Hello sir. ఆఫ్లైన్ క్లాసెస్ నోట్స్ కూడా సెండ్ చేయండి సార్. మేము ఆఫ్లైన్ క్లాసెస్ అటెండ్ కాలేదు సార్. కొంచెం
ఆఫ్లైన్ మీకు పంపించలేదు నేను.
లేదు సార్, ఆఫ్లైన్ ఇవ్వలేదు సార్ నోట్స్.
సరే పంపిస్తా.
ఓకే.